Hello everyone, today I'm going to show you how we can develop this parts drawing as a sheet metal in 3D model, Autodesk Inventor. Okay, maybe you can see one of the top views and the front view, two different levels, and folding over, and after unfolded as a flap pattern. Most of the dimensions has been located. And also this is mild steel, the thickness is 1.5. Bending radius is 1 mil as a default. Some information in here. So let's start. Okay, first thing I need to do is the base. Okay, so for the parts, this is still the parts, standard and sheet metal. I just started sheet metal and then create. Go to defaults. Defaults tell me the thickness is 0.5, so that's not good. I want to change that. For changing that, you need to click on the little pen. This is Edit Sheet Metal rule. First thing I need to do is the material. Remember, mild steel. In here, maybe they call differently. They can call steel mild. If you don't find it from M, mild steel, they must be under the steel. So you start the steel from here. All different one. Depends what you make it. Different standard, hollow steel, and different standards. Okay, so here, cast, carbon, alloy, and this one, steel mild. And then this one there, I want to change to 1.5 and save and close. Now everything changed to 1.5 mild steel. Same as the 3D model, we're going to use the sketch. For the base, I would like to use this X and Z. Checking the size, going back to there. Checking this size, that's 116 and that's 81. I would like to use the center. 81, 116. Okay, zoom out a little bit, you can see it. That's the base. We don't need to draw other parts. That's the sheet metal, how we do it. And we just click to finish. And when I finish, it is only the framework. I need to give a face. Remember we talk about the face, the defaults we change. They're automatically to making 1.5 mild steel. All you need to do is click on OK or apply. See the shade is the mild steel. I can see from here too, still mild. Okay, that's my base. Now I want to fold this part. 4707. You don't have to worry about 81. For folding 4707, just remember that. When you go closer, you can see two corners in here. That's important for your folding parts. When you go to flange, the flange tell you how do you do it. 90-degree bending, 25 mil bending up or down. That's the distance. Where do you bending to? And remember, we're talking about 4707. We need to change this 47.07. 90 degrees, that's okay. Now I'm coming to here to start bending. So the edge, I'm going to select it, this one or this one. What is the difference? If I select this one, they're going to bend up. If I select the bottom one, they're going to bend down. So that's only different things. Apply the bending up for me, 90 degrees. I would like to do the other end. You don't need to worry about the width if you want to do the full width. So the other one, 7341. I say 73.41. And then I bend this corner. It is a little bit longer. If I go back to the drawing, this side is longer. This side is shorter. What I'm going to do is bending these parts now. This is a little bit complex. This one there is from the whole panel is 116. You only bend 48.41 for this part. You plus 48.41 plus 25 on these parts. So that's 68. That's critical. Go to French function and come in here and bend everything up. So first I want to bend the shortened one. So this one there, that's 48. High is 48.41. Bending up is 48.41. There's no offset function in here. What I need to do is coming to here, you click on there, they give you an option. And first thing they say is corner, the edge. So that's the edge. I don't want to do the edge. I want to do offset. 5 mil offset, 5 mil offset. If I cancel this one, so that's this side. I don't want anything offset from the left because I'm doing this side offset. So from the top one, or from the right hand side, we put the 68 and this one is 0. Apply. The other side, this one 0, this one is 68. And then apply. Finish. Now I want to do this one now. Okay, so this one is individual now. It's individual. If I push on there, the whole length going to be extended. So that's the finish folding for the big parts. It is pretty much good for now. We're bending all around. Now we need to go making all these, all the plates, folding plates now. Okay, coming back to here, we do the same thing. It is 20 all around. If I change to 20 and still 90 degree, select 1, 2, 3, 4, 5, and 6. Apply. Okay, all around. You maybe ask me the question, it looks different. You don't have the seam together. Sew the corner and little seams in there. Same as here and here. But this one, we use different function. I show you this function is a corner seam. This corner and this corner, they seam together. You can't do too many. They only ask you which corner you want to do it. So this one. Apply. Okay, this one and this one. Apply. We're almost done all these. The leftover is this 1, 2, 3, and 4. Have a look at the direction. Direction will be here, here. So the opposite. This one go this way, this one go this way. And this one go this way, and this one go this way. How do we can do this? I always tell people using different functions. If I go to 3D model, I use a chamfer. Before we doing that, I must understand where do I want to do a chamfer. So chamfer is the corner, from the corner to there. I measured from this point to this point. And you can see it's 17. Okay. Then I go to chamfer and I say 17. And then I go to this corner. You see the corner there? And I cut it. And I go to this corner there and I cut it. And then this corner. Don't do it wrong. A lot of people say this one. That's wrong. If you click on there, you cannot do it. If you're checking from the top and you go back to here, you can see that's exactly the same. So that's the one we're looking for. Now all we need to do is drill holes. 2 different sizes hole. 1, 2, 3, 4. Same size. Diameter 6. And this one 1, 2, 3, 4, 5, 6. 6 holes, diameter 8. In between there, that's 25 mil. From this corner to there. And in between here is 40 mil. From here to here, we just put it in the middle. Because this is 20, so we put 10 mil in there. First thing, we need to find the center from here. I get a project magic. Let's draw a line there. So this is 17 mil. 17 mil is not the center. It's not from the center there, because when you're bending, you got 3 mil. So that's why you have 17 mil there. So I want to be from the top down 10 mil. So that means I just write down 7 mil. I just click on there and I say okay. And then I measure this and I put 7. So that's my point. And I need to put all around. I can make this construction, delete this one. Okay, so this one there, this one, again, we say 10 mil. From this edge is 10 mil. Now it's different. And then we go down to here. And okay, so on construction. From the corner, always 10 mil, not 7 mil. From inside this line, that's 7 mil. Okay, so that's construction. Then we have another one, say 10 mil, and going back down. Okay, if I tilting up, I'm going to draw the top one. From this side here is the longer one. That's the top one. That's the top one. I can make a turn. I can turn around to this side. So you don't make a mistake. That's 10 mil. We know the center line already. Now we need to allocate it where they are. Okay, first one 25 mil. Second one 40 mil. If I go back to here and I say from this point get a reference 25 and enter. And then the second one 40 mil and enter. And okay, this 1 and 2 points. I'm going to draw the hole now. This hole is 8. And I say 8 and 8. I'm going to draw a line in the middle See this? Because before I got the project magic, so that's the middle point. What I do is just draw a line there, and this is construction, and I just use the mirror function to mirror the L, this one and this one, and apply. So they go to the other side. 4 holes finish. Well, 1, 2, 3, 4. Now we worry about this. That's 25 mil from the edge there. If I draw a line there, doesn't matter you draw from the top or here, say 25 mil is in there. If I make a copy and then copy base point will be in the center, then I go to this one and I say escape. Okay, and mirror this one, mirror line, then apply to finish. Making easier for this side, I would like to draw this tool first because I can get a reference from there. This tool now is a 6 mil. If I get 2 here, see the reference line, and I say 6 mil. This tool has been done. I'm just working out last tool in there. 35 mil. So from here and get 35 mil. This one copy, space, come in here and done. I just get the reference. That's quicker way to do it. 6 mil. Okay, all the holes has been allocated. We know all the positions. Now we just drill through. By drill through, you must take finish sketch. You finish everything. 3D model, extrude. Cut through all, and enter. It's perfect. I would like to save this. Save as, and then save. After save, I want to show you, I say, oh, how do I fold this? How do I know the pattern? If I see this pattern, that's clear. If I got the Sheetmetal, I just cut this, cut everything. I can fold it, and that's okay. I got all the numbers there. You don't need to worry, just one button to fix everything, which is create flat pattern. If I hit on there, they will show everything for me. You see that? It shows everything for me. So you can add the dimension in, you can put anything you want in there. Thank you for watching.